Hey, David Alderman here, part 3, your brain on art, and we're focusing on neuroaesthetics. Samir Zeki, he's the grandfather, the Baghdadi, the godfather of neuroaesthetics. So today, we're gonna talk about constancy, which is, and it just like gets me all crazy even thinking about it sometimes. But guess what? More swag. And this is Retro Fitness, Zephyr Hills, Florida. If you haven't been to Zephyr Hills, Florida, you need to go. Yeah, you need to go. But Retro Flex Gym is owned by Jenny and Jim Taylor. And Jenny Taylor is, probably one of the greatest, or if not the greatest, female bodybuilder or bodybuilder. She's been to Olympia 5 times, and she has placed and been invited in all these different weight categories, and from figure to fitness to all, go read about her, go check her out. She's awesome. And if you're down in Florida, Orlando, or Tampa, run over to Retro Fitness, check them out, and they will treat you right. And they're really good friends of mine. Just tell them, David, the painter in Colorado, is kind of loopy, but they'll know who that is. All right, so let's get started, all right?
I think, in a way, you are asking the question in the wrong direction, if I may say so. I think the artists came before us. And I think they asked questions which we would ask, but they asked us on canvas. So they were studying brain mechanisms, but with methods unique to them. And I'll give you an example. What was the essential aim of the early analytic phase of Cubism? It was form constancy. How would a form maintain its structure when you view it from different angles, different lighting conditions, different distances? Now that is a question which is called form constancy. Physiologists are studying it now. Picasso studied it in 1911. So the question is slightly different.
You know how I like to read from the art book, right? So I hope you guys all have this now. All 5 of you that are, actually, I think there's about 40 people watching me now. So get this book. It's amazing. So here's a little piece, right? Around the world, healthcare workers are prescribing museum visits. Digital designers are working with cognitive neuroscientists to find new treatments for attention deficit disorder and to enhance brain health. There's a virtual reality program that alleviates pain. And because research shows that sensory-rich environments help us learn faster and retain information better, many schools, workplaces, and public spaces are being reimagined and redesigned. All because of advances in neuroaesthetics. And whew, it's awesome. All right, so what we got? Constancy. Okay, we have 2 parts here we're going to talk about. We're going to talk about color, all right, and forms. Okay. Color constancy. We say, I see this, I looked at this piece of art, and we've always, when we look at a piece of art, we think that we're what we see. And what we see is so we have our eye here, right? And this is a surface or a subject. And the surface or a subject, light hits this and reflects back into our eye. And we have these cones in our eye, and they're stimulated by the waveforms that hit the cones. And these cones will send a signal from the cells, okay, back over here, and it goes in here into the back here, all right? And that signal stimulates the cortex, and this is called the occipital lobe, all right? Go polish up on your neuroanatomy. But and this is called the visual area 1, okay? And we always thought we would do tests to test your visual, your whole nerve system, because people would say, hey, they're not seeing it correctly, or their motion or colors are not right. So we would test this, and we would know a normal value. We would stimulate the eye here, the cones in the eye, and this signal would go through here, all right? And we would put in an electrode here, and we would record this signal, okay? And this signal, something like that, and we know that if it's operating correctly, it would be like around 75 to 100 milliseconds. We'll say 100 milliseconds would be normal. If it was slower, then we knew we had a problem, and that was the problem with the visual area. But as we advanced and we started looking, and the neuroscientist and Samir, as they went down this, there were certain groups that said that we were seeing it in this area. But what they discovered is there's actually V2, V3, V4, and V5. And these were all these other areas in our cortex, and this is what's called the visual brain. And V2 and V3 are focused mostly on color, and 5 is actually for motion. And what happens is you could have a perfect optic nerve response, perfect when we do the test, but you still have problems with motion. And we found out that in the V5 area, there may be a lesion or some abnormality, and that causes a person not to be able to see motion. And it's the same thing in the color areas. So what happens is the signal comes into V1 and is broken up and sent to different areas of the brain, okay? And when that happens, the brain sees the constancy, okay? Because it remembers it, and that's why it's important, because it doesn't have to analyze everything. It recognizes it because it has stored it, all right? Constancy, color constancy. It remembers when the light changes a little bit, when you're looking at a piece of art or a tree or whatever, and you're turning and the sun is moving and light is changing constantly. It's constantly reflecting all the time and feeding back energy. Your brain does not have to reevaluate that and analyze it, because it's color constancy. It knows that the leaves are green, or what we're looking at is, you can distinguish it. And a good example would be like in low light, a digital camera. We may know that it's dark green and brown. We can see that, but the digital camera will see that very muddy. It can't determine it, because it doesn't remember. It doesn't have the functions of our brain. Okay, so it remembers color constancy. Okay, in everything. And we log this information early in as a child. When we go to a new place that we haven't seen, we're kind of like in awe, because it's just calculating it all if we haven't seen the color, but it puts it in we store these in categories, and it pulls it back. So therefore we know plants are usually green, tree trunks are usually a brown. It's color constancy what's going on. So it's not the eye that's seeing all the light reflections, and the light reflections are really waveforms. Okay, so they're like, let's say a red waveform, okay, is very long, all right, and a blue waveform is much shorter. And as these hit and they go into the retina here, they activate the cones, and the cones will react differently to red and blue. And yeah, it's amazing to think about. But what we're really seeing, we're imagining this through our brain, because we've seen the color, and it's color constancy, and that's throughout nature, is throughout everything. All right, so hopefully that makes a little sense. The next thing is form constancy. And form constancy is we recognize a dog. Okay, so a dog, you might look at the front of the dog, the side of the dog, the back of the dog. You recognize it as a dog. Okay, it doesn't have to analyze this again, and remembers these forms. And this all this is transferred to art when we look at art. Okay, when we look at art, you may look in the front, you may come over to the side, or the artist may show light in a different way, shadows, values, colors, and the brain can decipher this by color constancy and form constancy. And form constancy is really cool, because abstract art, and one particular art, of course, that I'm involved in is Cubism. And you can recognize what the subject is by very little form. So you can you're like, well, up, boom, and then you get it, because your brain remembers what forms are, and you need very little data to trigger that in, because it's stored in your brain as a file cabinet, and it pulls all these areas together. If they're not working properly, then no, you can't see color, or particular area you might not be able to detect motion. You just can't see it. And color is kind of cool. Color, it works where color is recognized about 20 milliseconds faster than motion. So you see color first, you see that red car, about to look out, because boom, it just hit you. So anyway, with form, we in art, it's been stretched, and the Cubists kind of really tried to really twist that, because they switched angles and colors and sizes. And then you had some of them like Gene Metzinger and Albert Geisy. They both wrote a book on Cubists, and that's a really good book to read. It's an old book, but it's really cool. And of course, we have Pablo Picasso, and these guys, Pablo, that cat, he was, he did some work that was so obscure that you really couldn't even tell what it is. They kind of stretched the whole form constancy idea, and the only way you could really tell what it is by the title. So that's kind of an area to talk about with the form constancy, how that works in art. But then color constancy, they take like an artist like Vermeer, and how he used the values and the colors, and we know that what color you use next to another color. So this could be a certain shade, value, and it could be just the same color, but different values next to each other will actually change how this registers in the brain. So color constancy, these are really how we look at art, and this is how we remember it, and how when we look at a piece, we recognize it, and then it brings in memories. It's not the eye specifically, it's the brain that's working to see the art. Okay. The other thing that happens is we have categories, and this a good example would be that of form constancy. When it goes into a category, would be somebody's face. Okay, so they could smile and it would be like, oh, they're happy, or sad, or cry, mad. Okay, those are all things that are form constancy. We remember those. We don't have to. The interpretation's not done at the eye. It's done back here at the brain. So it's really, and all these happen at a young age. So that's why at a young age you want to make sure, first of all, children are looking at other children, and art would be a great thing to get them involved in. It really makes a difference. So I hope this makes sense. I hope this makes sense. It's important because when I talk about my cubism, I hope this will work. And I'm just going over all these things because I want you to understand how I view art and how I do my art and what it means to me. And everybody can have their own interpretation, but this is how I come up with what it is that I'm doing, and that's all I'm trying to do. So anyway, man, that was a lot. All right, peace out.